Hi everyone! The purpose of our video today is to demo our product SigmaWatt. The first step we took in building SigmaWatt was to identify the objective of our simulation product based on shortcomings of current data center designs, namely energy waste and high electricity costs. To address these shortcomings, we devised a three-policy program to better allocate electricity and energy costs depending on server utilization during peak and non-peak demand. Our next step was to create a web interface to enable fast run times and to enable better statistical analysis from our graphical representations. In conclusion, we created SigmaWatt to merge our model and output seamlessly, to bring you one step closer towards a greener future. In creating our system, we addressed three major problems. Firstly, to prevent energy and power wastage, we monitor energy usage by tracking factors such as cooling, running servers, and basic electricity needs such as lights for the data center. In our next problem, we need to consider how to monitor variable and fixed costs. And to do this, we looked at the fixed cost of running the data center and the charge level of the uninterrupted power supply. We solved this issue by creating a comprehensive cost structure which generated final energy costs, incorporating health, heating and cooling and security and lighting costs. Finally, our product strives to optimize server utilization during peak times through our policies, which I will explain shortly. Our policies, in conjunction with graphical representations on the interface, can pinpoint the optimal number of servers required. So here you have our first policy. We've broken down our verbal ERG into three portions. So in this one, you can see that the policy checks whether the server has reached the maximum capacity of 100 or not. Once a server reaches maximum capacity, new customers are directed to another server.
Here we have policy 2, which is when customers are directed to the server with the least utilization. This technique is also known as load balancing. Lastly, we have policy 3. Policy 3 has a special feature of turning off servers when they reach a threshold of a user-defined idle time, and turn on more servers when servers currently in use are seeing high demand. This high demand threshold is set at the beginning of the run by the user. Two types of failures are modeled. One failure type is when there is a server power failure and the UPS helps supply power to the server while normal power is restored. Second failure is when the server fails due to hardware issues and all customers currently being served are rerouted to a different server based on the chosen policy. The failures are modeled by the bathtub distribution, indicating high probabilities of failing earlier and much later in a server's runtime. I would also like to mention some product considerations. Power is modeled by CPU utilization. In particular, server power usage is calculated from the amount of power used when the server is idle, growing linearly to the peak power consumption when utilization of the server is 100%. Server farm power consumption due to cooling costs. Consider the temperature of the water and overall server farm utilization as the main factors.
Here is the SigmaWatt web interface. The user is greeted with a login screen for secure access. After logging in, the user is directed to a page for inputting simulation parameters. There are sliders available for some of the inputs to reduce errors during input and to save time. The user can specify the amount of servers the simulation has, as well as the rate of power consumption, cooling temperature, and initial queue size that the simulated servers will experience. There are also load threshold and idle time inputs for use in policy 3 that was explained earlier in the video. The time to run simulation allows the user to designate how long they would like the simulation to run, and the time to initialize simulation is where the user can specify the initial time interval for the simulation to wait before collecting data to output in results. This is a measure in minimizing initialization bias. The time interval of data collection will help filter out data by letting the user determine interval of time for the simulation to collect data points to output in a plot. This helps the user by spacing out the amount of data to prevent cluttering and allow for faster simulations. Lastly is the policy types that were explained earlier. The interface has a brief description of each policy upon selection of the different policy types. After inputs are entered, click Start Simulation to begin simulating. The simulation results will be created in a new tab so that the user can always refer back to the SigmaWatt initialization page to create more runs and compare results between the different tabs. The plot displays values of the overall queue, the server utilization, and the PUE ratio, which reflects the server's efficiency or how much of the power is actually utilized by the servers. The user can select or deselect the different variables that they want on the graph, and they also have the option of zooming in and out of the graph.
Just looking ahead, we would like to add features like user-defined outputs to ensure that our clients are getting specific results that they're seeking for. Additionally, we would like to have user-defined policies to customize the product to match each client's individual needs. Lastly, we're looking to develop a mobile and a tablet app to help with the portability. Our business model consists of two segments. We have the standalone software that sells for $2,000 per unit. In addition, we have a subscription model that provides online support, debugging assistance, free updates, and a subscription to Titans of Simulation Today. We have priced the service at $500 per unit per month. If you're further interested in learning more about our product, please reach us at info@sigmawatt.com. Thank you.